Hello, welcome to my first fiber laser testing video, and this box is sent to me by the GweikeCloud in exchange for a review. Well, there is a big chance that I have to send back the product after the video, depend on the views and the sellings, but I accepted this because I'm very curious about this product. This is 20-watt fiber laser, and until those dyed lasers I tested several times on this channel are great for the wood, this is great for the metal, but also for the plastic. It's even in their title. And of course I will test it with different metals, but I'm also very curious how it performs with 3D printed plastic. Let's see the specifications. Well, the speed is 15,000. We already saw this number with those dyed lasers, but the unit there was millimeters per minute, and here it is millimeters per second. It don't have moving head in XY direction, but some mirrors are rotating the direction of the fiber laser, and that's why it can operate much faster. And the lifespan is 100,000 hours. I'm not sure if it's only for the laser or for the moving mechanism too, but this is more than 11 years if it operates continuously. Now, because of this moving mechanism, it is limited in the working area, and there are two versions. One is 110 millimeters in X and Y direction, and the other is 150 millimeters in XY direction. I think this is this bigger version. Also got several boxes here. This is the safety shield, the Rotary Roller, and the Chuck for the cylindrical objects. Now, I'm very experienced with those dyed lasers. Some company even involved me in their development phase, and I'm usually talking there about the safety. Now here I'm not quite sure, but probably we have to wear some safety glasses. I'm not sure how much fumes we will have if we work with the metal, but probably it has to be used in good ventilated room, and also you shouldn't leave it without attention. Of course, risk of catching the flame with those dyed lasers working on the wood is bigger compared to the fiber laser working on the metal, but anyway, you shouldn't leave it without the attention. And only later I realized that this is packed upside down and I don't have good documentation if I have to send it back. This is content of the box. So this is the main unit which creates this laser, which is transferred with this optical cable to the head where we have those mirrors. Probably these are some legs, we have some cables. This is the Z-axis and the workbench. This is the glass, and for the look it looks very similar to those which we have with those dyed lasers. These are some elevation blocks. Elevation block is useful if you want to lift higher this head to engrave some larger object. This is the power supply unit, Meanwhile, so this is great brand, and the output is 24 volts and 11.67 amperes. Quite strong. And we have some cables. Unfortunately, we don't have printed user manual, and it's not even included on USB drive, but it is available for the download on their website. First, we have to connect these three pieces together, two bolts from the bottom, and this is the head holder, which can be even tilted. And I think there is a hole if you want to make it perpendicular. We don't have to guess or measure. These are some limiters we can mount here on the workbench if you want to repeat some engraving several times in the same position. Actually, this is the back side of this unit. Here we have the switch for the laser source, and this is the emergency stop button. I connected the cables. This is the optical cable for the laser, which is permanently connected, and this is ribbon cable. Pay attention to the direction of the connection, because almost it can be pressed in both directions, but there are some marks there. This is the input for the main power, and this is exit for the power supply for the Z-axis motor, and this is the DC output for the head. On the head, this is the input for the laser, this is that ribbon cable, DC power, and this is the connection with the laptop. And then we have some LED, reset button. This is power for the fan if you want to use that shield, and this is a USB connection for the rotary unit. It uses the fixed focus, and it can be set with moving the Z-axis with these buttons. And we can set it with three methods. One of them is that we have two red dots, and we have to move it until it's aligned. The second method is with the ruler, and this version needs a focus of 261 millimeters. And the third method is using this protective shield, which has also the length of 261 millimeters, but that's more for the handhold mode. In the meantime, I printed this distancer 261 millimeters, and it has some kind of spring here. The software I will use is the GLaser. First I started to use one which arrived with a USB drive and it worked fine, but then I downloaded the latest version, and from that on the coordinate was rotated, the scale was up and similar. And actually the problem was that the new version has to be configured for exactly this one. It was configured for the smaller version. And just for my reminder, F3, and then I have to import here this file here. This is the configuration file which is on USB drive. This is the content of that file. And first attempt I try to engrave some text, and to change the content of this text I can do it here, and very important, I have to click apply. This is just an outline text, and if I want to fill this, I think this has to be done, yes, with here, fill. Let's leave the default settings. With F1 I can see the preview of the image, but only a rectangle. If I want to see the outline, then I can turn on with this checkbox, and now I can see the text too. And actually I did all this with the main unit switched off. With this it is quieter, but also I'm preventing that I will start accidentally engraving before I'm ready. And now I will turn on the main unit. And with Mark or F2 I will start the engraving. The safety glass is on. And this was real-time footage. Looks like my first attempts were better off camera. Here I can see only outlines of the letters. I'm missing here the infill. Let's try one more time. The previous to be 2000 mm per second speed, and now let's try the 1000. Oh yes, definitely. This is now perfect. From the default settings, 1000 mm per second, 50% power. Next, engraving a grayscale image. And this is the Padme from the Star Wars, which I'm always using in this kind of videos. And for my reminder, I have to reverse the image and enable the outlets. And 2000 mm per second and 50% power. Preview of the position. And this is real-time footage. And this is speeded up 30 times. A time-lapse video. Finished in 2 minutes and 40 seconds. There is some warping of this plate. Oh, and this looks perfect. And yes, I could see some fumes during this engraving, and definitely it has to be used in good ventilated room. On the head we have a reminder that we have to clean the lens cover at least weekly. Let's play a little bit more with anodized aluminum. So this podcast was in the package with the engraver, and these tags are sent to me by the Chewbacca company, and this is engraved with diode laser, and probably I can do something similar or even better, but much faster. The positioning is so easy compared to the diode lasers. Similar like with the diode lasers, not so sensitive to settings, engraved with 1000, 2000 and 3000 mm per second speed. The raw aluminum is completely different story. It is not even listed in their parameter table. I will give it 10 passes. This was real-time speed. The engraving is there, I can feel it is rough surface now. Now I want to finish the video here, but to handle those fumes, I'm using this very old vacuum cleaner, but it will do the job as a temporary solution. Yes, definitely much deeper. Let's try to measure it. Hardly measurable, maybe 0.01 or below it, but definitely visually it's there. Let's check it out under a microscope. And I will try 100 passes with the crossfield this time. Maybe 0.01 millimeters. The copper is also not listed in this property table. I here tried just one engraving. So I'll try the same settings also with 100 passes like with this aluminum. Almost nothing visible, so definitely this cannot engrave copper. Let's check it under the microscope. But let's try to mark it using this Brilliance laser ink, and I already did a review of this testing with diode lasers, but only with 10 watts. Maybe I should do that with the 40 watt diode lasers too, but let's try to use it on this coin. I just stopped the engraving to check, but there is no marking on this, so it cannot be used with the copper. But the brass is completely different story, so I'll do some test engravings here, and then I will try to make some coin. And this is really deep. Let's measure it. Wow, maybe 0.08 millimeters. Now, engraving of JPEG image is quite limited, and I don't have so many setting possibilities, so I converted it to vector graphics using the Inkscape, and then importing the SVG file to the GLaser. And very important, the newest version works correctly. The older one has some problems, and this is the reason why I downloaded the latest version, and I started using this one. As you can see it on the clock, this is speed up video, and this time I didn't forget to enable the vacuum cleaner. It's finished. Wow, this looks great. For the look, for the feeling, it is very deep. Of course, to have a real coin look, this actually should stand out, so this means I should remove the material next to it. Let's check it under the microscope. And this depth is approximately 0.1 millimeters. And it's time to engrave a steel. I have some regular steel, this is cutting from a bolt, and also I have some stainless steel plates. This side earlier I used to engrave with the Brilliance laser ink. The marking is there, but not too deep. Let's try, I don't know, 50 passes maybe. The marking is definitely there. It is quite hot, I can hardly hold it in my hand. The marking is not deep, but very visible. It looks like it oxidized the layer. Let's check it under the microscope. Well, I think this should be the stainless steel. Let's engrave here MTF logo. Not sure if you can see this fine metal powder. And this is something what you don't want to breathe. Well, I made this bolt earlier. This is left-handed thread and this is right-handed thread. And let's engrave here R and R letters. The engraving is there now and it's permanent and it is now obvious. So this is the right-handed bolt and this is the left-handed one. This is also regular steel, and I will engrave here the MyTechFun logo and only the outlines. One more time with 100 mm per second speed, 200 mm per second, 100 mm per second. Just one more tool marking, I really have fun with this. And all this was real-time footage, and I can feel that it is deep engraving. And now just outline, and the speed is 80 full power. And this was real-time speed. I hope I will not destroy the USB drive. Speed is 100 full power. Oh, I can feel the engraving, and let's check if it works. Yes, it's there, I can see the content. Well, somebody claims that it can remove the rust too, so let's try to remove one small spot. Wow, it works, and it was done in few seconds only, and it doesn't change the dimensions, so let's check it under the microscope. What I can see here is that mostly the layer of the rust is removed. Small disclaimer, this is not my tool. I don't have these rusty tools. I borrowed this and I need some experimenting with it first. The method definitely works. I did some experimenting here, and when it is a little bit lower out of the focus, there it needs or readjusting the focus or a few more passes. If the owner needs the other half clean too, then he have to pay for it. Color engraving on the stainless steel, and this Word document I got from the GweikeCloud. And I have to prepare here the test cut, which will be just few clicks in the LightBurn, but here I needed at least 25 minutes, so definitely this user interface needs a lot of improvement. The focus is set to 263 mm, 2 mm above the surface, and this is again a timeless video. Power from 10 to 50% and a frequency from 20 to 60 kHz. And I want to repeat this blue color, first here engraving the MyTechFun logo, and later I want to try the same color on this coin. I tried to repeat here these three colors, and more or less they are similar, but now let's try to get this blue on this disc. For these three colors I use the same settings, but as you can see they are not completely the same, especially this one. It is some kind of blue, but a little bit different than these two. So this means that you have to experiment all those settings for exactly the material which you want to use if you want to repeat this kind of color engraving. This is PLA plastic. This will be 3 passes on 500 mm per second speed, 75% power. This was real-time speed. The marking is there, not so nice, but the plastic is melted and that's what it leaves the mark, but not super nice and accurate. This is 3D printed ABS. But this was finished in less than 1 second. This is PETG, same settings. And it's there. Because of the color it is a little bit harder to see, but it's definitely there. Polycarbonate, same settings. Nice. This is nylon. I'm curious if I can see something on the black surface. Depending on the angle of the light, I can see the engraving there, but on the black surface it is hard to notice, but it's there and it's permanent. So from 3D printing materials, only with the PLA filaments I don't have nice results, but with any other I have very nice markings. Of course it is hard to notice those lines on the black surface. Engraving a rock, and I'll try only outlines first. Outlines are not really visible on it. Wow, this was surprisingly good. I know this is approximately half millimeter deep. With these settings, yes, really we can engrave stone or rock. 0.63 millimeters, so it looks like we don't even need 10 passes. Maybe 2 or 3 passes are enough to have some marking on the stone. And I've tried the Rotary Roller, a holder for the cylindrical objects. We have the unit with the cable on it. Let's connect it with the head, and actually this will replace one of the axes. Even in the highest position the distance is not enough for the focus, so I'm using these rising blocks and I'm using these 3D printed objects to set the new focus. Now as you can see I experimented a lot with this Rotary Roller unit until I understand how it works, because there is no good documentation about it. And I want to explain here for my reminder too. This is the object I want to engrave. I already give it some infill, and then Rotary setup, split mark, config, and these two checkboxes are important, and also here to set it to be a roller. Okay. And actually this I needed at least 2 hours almost to figure out what are these. So this movement is actually a segment. As you can see now it is 5 millimeters, so it is split to these 5 millimeter segments, and it will do one engraving of one segment, and only then it will rotate and do fast engraving of the next one. And on the workpiece actually this is the radius of the object itself. And I still don't know what is this, but if I click here the red, then actually it will show us the position of one segment. And with the mark it will do the engraving. This is the preview position of the first segment. I will stop now this preview and start with the marking. And you can see those 4 segments which are engraved. Aligning of the segments may be inaccurate like here. Can somebody confirm that this is how it works from LightBurn with some similar fiber lasers? And with this you can see that we can engrave a cylindrical objects too. Or we can remove the rust from cylindrical objects. Well, it works, but it looks like something I didn't set correctly, so I can see some gaps between these segments. But as you can see, yes, you can remove the rust from cylindrical objects too. And I decided to finish this job completely, so off camera you can see it is completely removed from the rust. And now let's see how Chuck works. I noticed it stuck, so these arms should go into this groove, but it stuck. I think it should go a little bit back. Maybe 1 or 2 millimeters. I'll try to lose those sets because I'm not sure if it will help. Okay. I noticed later sometimes with some tilting we can fix this problem too. This mechanism is very hard for use, not practical at all. I saw much better solution for this, but that's right. And this cable is too short for the Y-axis engraving. I think I can use it only in this position. And now let's see the Chuck settings. This is the same object, rotary setup, split mark. And in configuration, rotary axis, this time it is check, and I disable this reversal. And I noticed that here number of pulses is 3200 compared to roller. Maybe this is the reason why here I have to enter the diameter and not the radius. And this is again the dimension of the segments. This time along the x-axis, so this is a segment of 5 millimeters. And if I click here, then I can see the position of the first segment. And with this I can start the engraving. Maybe here I have some space. So it is this one. The cylinder is quite full, but I'll try with some bolt. Both with 100 millimeters per second speed, but this one with 0.03 line and this one with 0.06. And now let's try the handhold mode. Just snap in and then it will be held in the position by magnets. Let's connect the fan. There. And now let's engrave MyTech1 logo on the side of this main unit. No, just kidding. If I have to set it back, I don't think they will be happy about it. But who knows, maybe it will be a unique piece. Unfortunately, with this handhold mode, we are limited with these wires, and I think this main wire optical cable would need a little bit better strain relief somehow. I don't feel too comfortable to move it around. And looks like this exhaust fan is always on. Probably it will be better if it will turn on only when the laser is operating. This was just a demonstration on black injection molded plastic, so this is the outline. And this is some field engraving, and I can feel that this is approximately 0.2, 0.3 millimeter deep, and this was only one pass. And I can feel the depth of the engraving. And now everybody knows. Now, strange, for this handhold mode I have to hold it in this position, otherwise upside down it will fall off, because in this mode I can take it off, and in this case design must be upside down. And here you can see the rest of my settings for this engraving. Today I wanted to record the conclusions, but my youngest daughter is sick, so no kindergarten today, so let's find some quieter place. First I will talk about things which I really like with this laser engraver, and my favorite thing is engraving the anodized aluminum. We can actually get a photographic quality of it. The next one is marking a steel or stainless steel, and if you use only the outlines, the engraving is super fast. Of course we can mark many other materials too, but I'm talking about my favorites now. Removing of the rust, and for this open-end wrench I needed approximately 5 minutes for half of it. And then deep engraving of the brass, and with this we can create some nice coins. I wanted to order some brass discs, but so far I could find only quite expensive one. Somehow I don't want to pay more than $1 per one disc. These I made myself, and I think they should be much cheaper. If you have some good source in Europe or worldwide, please send me a link. About this color engraving on the stainless steel, I don't think I will use it too much. It is nice that we can do it, but it is hard to repeat it continuously. I noticed if the material is a little bit preheated, then again we will have a little bit different colors, so it is hard to repeat exactly the same colors if you want to do something for the customers. The preview of the positioning is super helpful. I am missing something similar from the dyed lasers. We can exactly see the location of the engraving before we start. About the Rotary Roller unit, it is a good design because we can place even longer objects on it. There are no stepper motors or valves in the way or something like that, because I saw some bad designs earlier. Of course, I don't really like this segment engraving, but I think we don't have a choice. On a dyed laser it was much simpler because there we just replaced the Y-axis stepper motor with the Rotary Roller stepper motor, just replacing the cable, and everything is prepared. But here this must work differently because this stepper motor cannot rotate so fast as the fiber laser is moving. So that's why we need these kind of segments. About the Rotary Chuck, well, this design I don't really like. First, that is not comfortable method for placing, locking the position of the object inside. If you want to do this in mass production, definitely this is not comfortable for the use. And also, I'm not sure, it's always stuck in that groove. Instead of that groove, maybe they should just cut out and to have some kind of legs, like on this picture. And now about the software. And I think this is the weakest element of this product. It is quite limited. Of course, we can always very easily place a text and do some marking and something like that, but if you want to do some graphic design, definitely you will not use the GLaser for this. You will do it in Photoshop, for example, if you want to prepare the JPEG image, or I don't know, Inkscape or something similar. Now, it can import a JPEG image too, but in that case we are quite limited with the infill possibilities. So if it is not a picture but some graphic, better if you convert it first in the Inkscape, for example, and import into GLaser. And this is very important function, importing correctly. And the old version, here you can see the number, had a lot of bugs with this. I have also some problems, but the newest version works perfectly. So far everything I tried works great, and I could import any SVG file here. Some elements which I am really missing from this GLaser is estimated engraving time, for the longer engravings of course, or when I start engraving, the remaining time, or at least the pass count, especially with that, I don't know, deep engraving, I want to do 100-200 passes, it would be good to know when will be it finished. And always pay attention to the safety, so always wear those safety glasses, and if there are more persons in that room, maybe you should use that protection shield too. But I think the most important is to handle those fumes, because that small metal powder is something you don't want to breathe in. Since the area is small, you can place some pipe there, in my case for the testing the vacuum cleaner, but you can just buy some pipe and inline fan, and that will handle those fumes to exhaust them outside. As you can see that these settings really needs a lot of experimenting. Until with the dyed laser we can just play with the speed and the power. Here additionally we have the frequency, we have the number of the passes, the layer thickness, sometimes even distance of the focus may affect to the color engraving, for example. So this means that you have to do some experimenting for exactly that material you want to use in, let's say, mass production. Can I recommend this product? Well, depends. You can see this is not really cheap tool, and you need some paid projects to pay off. Quite expensive for the hobby machine. Now the lifespan is very long, more than 11 years if it operates continuously, so you don't have to plan only for 1 year, but definitely you need some paid projects to pay off the machine. For example, I bought a lot of small discs and I can engrave there some custom graphics, but only for friends. I don't work this for the customers. So this was my first experience with the fiber laser. It was really refreshment after all those dyed lasers, completely new possibilities. If you have some other suggestions or experience, or you know where can I buy those brass discs, then write me 4 lines down in the comment section. Thank you for watching, and happy and safe engraving!